and again, all of that effort, there's significant money, and that's NASA, so that's your tax dollars at work, that are being spent on trying to get to Mars. So will we get to Mars? Absolutely, I have no doubt. Will we ever colonize Mars and fulfill Elon Musk's dream of having cities on Mars? I highly, highly doubt it. If you think that, ask yourself when the last time you vacationed on the moon was. All right, I believe that is the last question. Oh, yeah, that's pre-asked question. Let me answer the second part of that real quick in more detail. I don't think it impacts Christianity. I don't see any reason why it would. If we suppose that we do eventually colonize Mars, and let's go even farther. Let's say that eventually, to escape the death of the sun, we manage to escape far into the depths of space to some remote planet, and we set up shop there. I fail to see how that impacts our existing faith whatsoever. I believe that the gospel lives on, and that it survived for 2,000 years in conditions that are not unsimilar to colonizing unfamiliar planets. It certainly survived the colonization of the Americas and the world exploration of the last several centuries has been used, and all those things that survived to grow stronger in the process. So I don't see why we would be too impacted by that. All right, that was the last pre-asked question, so we will open it up now to Q&A live. I will come over here. I know I told you I'd answer a question earlier. I don't remember what it was, though.
I think it was space and time continuum fabric.
Yes, okay. So, yes, I remember what it was. That was good. I knew what I was talking about there. Okay. So, I'm going to give you the most cliche, but also the simplest explanation of space-time. You can think of it as a fabric. Mass is gravity is the go between space-time and mass. And so if you collect a lot of mass, like Earth, and you put it in space-time, then Earth bends it slightly. So let's pretend this is flat for a second. And then you put Earth, and oh, look, it bends ever so slightly. And then if you have something heavier, like the sun, it'll bend more. And then if you have a really big star, it'll bend more. If you have a black hole, it folds in half, this rips, and you get an infinity. And it's really weird. And essentially, you end up with, if you're trying to define that, you end up with a zero, divide by zero, which, if any of you remember your math classes in high school, that's a problem. Dividing by zero never ends well, and actually, we don't have any physical idea of what that is. And that is what lies in the center of a black hole, which, that's how they get their name. They are a hole through space-time. So, yeah, space-time is bent by the gravity of massive objects. Earth hardly has any impact on space-time at all. It is simply not very large. Yes, Steve?
Can you give the super basic version is that if you were to leave Earth and go like near the speed of light for like 20 minutes out and back, your time, because of how it works, we would here in time have passed an extraordinary amount of time. Because the idea of how all of time and matter and speed work together are, this is the theory of relativity you heard from Einstein. Everyone thought he was a nut when he said it, but it's been really proven. So the idea that large objects cause time to pass differently,
yes,
at the same time as us, will make your brain.
Yes, so this is referred to as time dilation. So if you travel at the speed of light, essentially, oh, we have a whiteboard. I can actually draw this. So essentially, space and time, you can think of as vectors. Don't get scared, I know it sounds like math. So essentially, the faster you travel through time, right? So this is time, this is space. Great, okay. We all experience time passing at the same rate because we can't travel very quickly. So you can't travel very quickly. The theory of relativity, essentially one of the consequences of it is the faster you travel in time, the slower, or faster you travel in space, the slower you travel through time. So if I move at an extremely high velocity through space, then my distance I travel in time is not very large, whereas the distance I travel in space is very large. And so if you travel at the speed of light to wherever and back, you would find at the end that you actually did not age at all, while everyone else did. It's very tricky. However, you don't have to worry about that, because one of the other consequences of relativity is that nothing with mass can achieve the speed of light. The total, your top end speed limit that you're able to achieve is limited by how massive you are. So particles of light, photons, have no mass, so they travel at the speed of light. But the electron, despite having a very low amount of mass, would not be able to travel the speed of light. It would be able to travel a very high fraction of it, but not the full 100% speed of light, because it has mass, which is a common those ways. All right, space-time question. That was good. Questions? Yes.
So if you don't think that we'll ever colonize Mars, do you think that it's possible to be colonized anywhere, or is the whole field of exoplanets just meaningless?
The field of exoplanets is not meaningless at all, but the public perception of our interest in exoplanets being to eventually colonize them is a big misconception. Now, NASA is fine with that because NASA is reliant on your tax dollars to do research. So the more relevant NASA can make their research and their ideas seem to taxpayers, the more support there'll be for NASA, the more money they get. This is why in the 60s, when we went to the moon, there was a big push to make it about beating the Soviets. Because if you made it a political thing, then it made it much easier for Americans to swallow funneling millions and millions and millions of dollars into the space race, whereas if we did it just because we want to be first on the moon, yay us, you would have been a bigger problem, and you wouldn't have as much public support. Exoplanets, though, are right now probably the single hottest area of astronomy research. It and gravity or galaxy research because of James Webb, which is Webb's specialty is galaxy research, which I may be working with at Toledo. Shameless self-plug there. But yeah, exoplanets right now, exoplanet, for those who don't know, is any planet that's not in our solar system. First one was discovered in something like 1997, 1998. To date, there are 5,000 of them counting that have been discovered. We're discovering more all the time. Discovering exoplanets is really tough because planets don't emit any light of their own. And so essentially what we have to do is we pick a star and we stare at that star with a telescope. We measure the light, again. And we measure the light output of the star against time. So if we stare at a star for a long amount of time and we see this, then that's a star and its brightness doesn't change, and that's great. But if we stare at a star and we see this, well then that's really interesting, because this means that the star either got dimmer or there's something eclipsing it, something passing in front of it that's blocking some light. And we get really excited if we see this, because this is periodic, meaning that there is a set amount of time that's occurred between these intervals. And the more of these we get, the better, because if we have this, then this establishes regular behavior. What are planets? They are regularly behaving objects. They orbit at set distances and for set amounts of time around the sun or around the stars. So there's a lot of detail that goes into this and confirming that this is indeed a planet and not a whole bunch of other things that could cause these dips in light. Like essentially what we have done is use this method called the transit method to find roughly 95% of the exoplanets we have managed to find to this point. The problem with this is that planets are really small, as we discussed earlier. If you're looking for the Earth, you're looking for something this big around a star that is, music stand, 2 feet. So it is going to block a fraction of a fraction of a fraction of 1% of the light coming from the sun. Problem with this also is that we are not able to stare at stars for a long amount of time. And so this is actually one of the biggest problems in astronomy research, is that everything is essentially shared by the academic community, which means that most projects in astronomy happen on short timescales. So if I want to study a star for 10 years and have every night take observational data, I have to have my own telescope, because I'm not going to have Hubble be able to look at the same star for me every single night. That's a problem, because if we have a short amount of time, then this behavior that we're seeing repeated inherently means that we are seeing planets that orbit their star very quickly. So the overall majority of stars that we have, or exoplanets we have found at this point, are exoplanets that orbit their host star in a matter of days. And this is a problem, but it's one that we are working to correct and build more sophisticated equipment and build out projects that are specifically meant for longer term studies. Yeah, exoplanets. Very cool. Questions?
Pluto.
Pluto. All right. So this is probably the most.
Some of us are loyal to Pluto.
Yeah.
So,
Yeah.
I just need you to know.
Yeah.
We grew up with Pluto.
Yeah, if you want, you go on Amazon, type in like Pluto's a planet, you can buy all kinds of merch that say Pluto's a planet, you know, restore Pluto and all that. All right, so Pluto is not a planet, and it should not be a planet. I hate to burst your bubble. I also hate to burst your bubble, but Neil deGrasse Tyson, who is probably the only physicist everyone in this room is familiar with that is currently alive, is also chiefly responsible for getting it kicked out. So if you want to yell at somebody, you actually find interviews with him talking about getting hate mail from like fourth graders to write them saying, you kicked my favorite planet out of the solar system. But it shouldn't be a planet, and the reason is this. There are generally 3 rules set for planets for an object to be defined as a planet. And that is because there's a lot of crap in the solar system that goes around the sun, and so we have to be specific about what constitutes a planet. So rule number 1, we have to be large enough to be round. As things grow in mass, gravity generally crushes them into a ball. And so if you're not very large enough to be crushed into a ball, we immediately don't consider you a planet. This is why things like asteroids and comets and all that space junk are not considered planets. I said there are 3 rules. There's also kind of a second one, and that is you have to orbit the sun directly. So the moon is round, not a planet. Why? Because it orbits Earth. So you have to directly orbit the sun to do that. That's kind of the hidden 4th rule that doesn't get discussed, but Pluto does check that one off the list. It is round, it checks that one off the list. The other 2 rules are what got it in trouble. So the 3rd rule is, or really the 2nd rule, is you have to have cleared your orbit of debris. And so, again, there's a lot of stuff floating out in space, and if you are a planet, one of the rules is that you have to have basically enough mass that your gravity has pulled in all the junk from your orbit, either onto itself or flung it out elsewhere. Pluto has not done this. Pluto routinely goes through the largest collection of asteroids in the solar system. So you're probably all familiar that there's an asteroid belt between Mars and Jupiter. There is, but that one is very tiny. There's something called the Kuiper belt, which is really more like the Kuiper cloud that exists on the outside of the solar system. That is basically everything left over from the formation of the solar system that didn't get pulled into something. Pluto routinely goes into the Kuiper belt on its orbit. And so it is not clear its orbit debris, and so that's a problem. And then the one that ultimately was most important, and the reason why this actually got considered for discussion, is we know from the way the solar systems form that sun and planets will all form generally in the same plane. So if the sun is here, then all the planets will form within plus or minus 5 degrees of the sun. Make sense? All right. Pluto is at like 45 degrees. It's all the way out here. Now, we suspect that that means that it formed differently than planets did, and that it, for all intents and purposes, does not share the same history that the other planets do, and the process we can generally consider relevant for planets. So that's the reasons it got kicked out. Yes?
What's the name of the guy that ousted Pluto?
Neil deGrasse Tyson.
Can you say that slower?
Neil? Yes, I'll actually write it. I'll do one. I will just write it on the board.
So weird.
And we can all write hate letters.
It's on TikTok, you can send it to TikTok.
Yep.
So what is Pluto, if it's not a planet?
Pluto. So Pluto is so unique and special that it did get kicked out as a planet, but it got to be defined as a brand new thing. And that brand new thing is a dwarf planet.
So it wasn't the first dwarf planet? They created the term?
Yes, and we created the term for Pluto, and we have now applied it to a few other objects in our solar system, and some others that we have found. So they are, as it sounds, objects that are big enough to be round, but violate some other rule about planets. And so they get to be called dwarf planets rather than just a planet. Yeah.
Would it be possible that when it goes through the belt, the asteroid belt, Pluto, like one of those would be big enough to like boot it out of its orbit?
The asteroids, no. Pluto is absolutely big enough, though, to send all of that junk somewhere else. And so there are lots of ideas about where, because our solar system is so generally stable, there are comets and large asteroids that go through the Kuiper Belt as well, who disturb the Kuiper Belt and have the possibility to send those objects careening towards the inner solar system. And we believe that Pluto may have been one of these objects in the past. Earth also experiences high number of impacts every 26,000 years, which is peculiar. We notice it in the geological record. We don't have an explanation for it, but it is periodic in behavior. So we believe that there is something, probably at least the size of Pluto, if not bigger, we have not detected yet, that is making its way around the sun, that goes through a field of debris every 26,000 years or so, and disturbs it, sends it towards the inner solar system. All of that, though, is still very much theory and observational proof. Yes?
When planets hit asteroids, does it make a sound?
No, so they're in space. Yes, there is no sound in space. I am a massive Star Wars fan, and it is the biggest lie that Star Wars told. There is no sound in space, which is upsetting because I really want to shoot space lasers and make that sound. Yes.
How fast is Pluto?
No idea off the top of my head, but very slow. It has, its orbit is at least like 100 years, probably. Because Neptune orbits every like 75 years, and Pluto is a full 25% farther out than Neptune is. So I would guesstimate off the top of my head over 100 years. Which means it has not completed an orbit since it was discovered. Questions? Yeah.
Okay, please talk about Planet 9, the possibility that there's a ninth planet in the solar system?
Yes, so this actually ties to what I just said, that there may be an object that orbits the sun we have not detected, that disturbs the Kuiper Belt and sends things towards the inner solar system. That, one of the ideas about what that object may be is a ninth planet. Now, one of my favorite quotes about space, and forgive my language here, it comes from the movie Armageddon. This is the only scientifically accurate thing that happens in that movie, by the way. Giant asteroid is hurtling towards Earth, and one of the military guys it's the size of Texas, apparently, according to the movie. And one of the military generals asked the head NASA scientist why they haven't been able to detect this giant asteroid. And his response is, well, because it's a big ass guy. And that is the most scientifically accurate statement made in that movie, and it's true. So if Planet 9 exists, the question is, why haven't we found it? And that's the response. Because the sky is really, really big, planets give off no light of their own, and so we have to detect them using other methods. Jupiter, Saturn, Venus, Mercury, and Mars are all visible to the naked eye, and they visibly behave differently than stars. And so the word planet is a Greek word. It translates as wanderer. And so they got that name because when the Greeks looked out the night sky, they realized that these 5 little lights were moving differently across the sky than the other little lights. So they named them wanderers. So that's how those were detected originally. That was centuries before we understood what they were. But that's how the visible planets were detected. Uranus and Neptune are not visible with the naked eye. They were detected using math. People were analyzing Saturn's orbit, and they realized that at one point in Saturn's orbit, it is disturbed. It gets pulled on by something. And the only conclusion was there had to be a massive object that was large enough for its gravity to disturb Saturn's orbit. That object ended up being Uranus, which is the proper way to say that, by the way. And then similar methods were used to detect Neptune 20, 30 years later. But they were detected using math. Yes?
I think the same reason that we discovered Pluto too, because Neptune wasn't exactly where Neptune was supposed to be.
Yes, so Pluto's orbit is another problem with Pluto. I mentioned its orbit goes to the Kuiper Belt. It also eclipses Neptune's orbit every so often. So Earth's orbit is almost perfectly circular. Neptune's orbit is kind of elliptical, so it's not perfect circle. Pluto's is really elliptical. And so most of the time, Pluto is the farthest object from farther than any of the 8 planets from the sun. However, there are times in its orbit where it does come closer to Neptune, which is how we have Herschel.